Hello, guys. In the previous videos, we had just done with our unit 1 of the data analytics. In this video, we will move on for the second unit. Before moving on, let's have an analysis of the second unit part. What really the second unit is all about. Topic of the second unit is data analysis. You know, we are going to do this analysis part here. So for this, we have topics like regression modeling, multivariate analysis, Bayesian modeling, interference and Bayesian network, support vector and kernel methods, analysis of time series, you know, linear system analysis and non-linear dynamics, rule inductions. In the part of the neural network, we have learning and generalization, competitive learning, principal component analysis, and neural network. Then we have a fuzzy logic, extracting fuzzy logic models from data, fuzzy decision trees, stochastic search methods. Okay. Now let's move. Understand this chapter actually. See, we have to go for the data analysis. For data analysis, how we will proceed, we need to understand. For the data, it's not like first time we are going to do data analysis. Data analysis is the main theme of the computing world from the ages actually. So initially the data analysis has been taken care by first of all storing the data in the database, and after that we get reports in the tabular formulation, and then yeah, we are okay with that. As the time passes, technology evolve. We are about to give Excel reports. Then again, technological refinements from that data available to the system has been connected, interconnected, and a whole under small silos of the data were created. Then silos of data were connected towards a larger order and try to make a warehouse where all the data is stored. And on that warehouse, we used to process algorithms, and after processing many algorithms, we got actually we got this part. We got not data mining patterns, and then and after the patterns we usually go through for decision, which helps us decision making. In between, we have a subjects like and a knowledge-based decision making. We used to we use those knowledges for the decision making aspects with the help of the data mining and the data warehousing. Now let's understand the thing, how it's all going on. It's all on the way. Okay. Okay. So after data mining, where in the data mining actually we have many methods to take care of things like clustering, decision making, clustering, decision making with the help of the clustering, decision making with the help of you know vector graphs. This is a we actually we use various techniques. In that we have invented very Applied algorithms and three ID algorithms and all. Okay. Okay. And in parallel we are also focusing toward the artificial intelligence aspect. When we try to push the mapping of human brain in the computing. Okay. So there we also use different algorithms like A-star algorithm and all, which would try to make a genetic structuring, implement the genetic structure and pattern thought process, how we inference the thing. So this all were here parallelly going on. and it's all with the evolvement of the technology. We came across that we can train a machine also for our purpose as we train our mind, with our experience and age, and it's taken care by the some algorithm checks. Like we have an example in regression modeling. We can we can implement this regression part, the various aspect of the problem. Then we have multivariate analysis. Then we have Bayesian modeling. Then we have inference and Bayesian networks. Then we have support vector and kernel methods. These are some not typical concepts which were in the statistics actually, and the data statistics part has been improvised in the databases, and databases were used to mined within the algorithms from the data, from the design analysis of algorithms, and then finally that things take care, things have been taken care. And now in the first unit we understand that we are getting the source of the units of the signals also. So that signals and time, that signals part has been taken care of with the time series analysis. We have a linear system analysis and non-linear linear dynamics. This depend upon the machine structures as well. Then we have a rule inductions in which we try to frame a rule for the inferences as well. Then we have a neural network, to how to make the things count, as a human being, to make a neural network where perceptrons will help us to finding the new pattern within the data mining, within the with the help of the data mining. So then we have our this part. We have our fuzzy logic, which help with extracting the model. We have our fuzzy decision trees and the stochastic search methods. So this is the whole unit is all about the machine learning, which is not written out here. Hello, yes, that's why when I will start this lecture, actually, I will give you an introduction of the machine learning, how this all machine learning aspect is all about. Then we move toward the regression modeling. So first of all, for for the better data analysis, first learn what really the machine learning is all about. See, what is machine learning? Machine learning is a form of AI that enable a system to learn from data rather than through explicit programming. Okay, however, machine learning is not a simpler process. As the algorithm in just training, it is then possible to produce many precise models based on that data. Machine learning model is the output generated when you train your machine learning algorithm with data. After training, when you provide a model with an input, you will be given an output. Okay. For example, a predictive algorithm will create a predictive model. Then when you provide the predictive model with data, you will receive a prediction based on the data that trained the model. Okay. Next is iterative learning. Machine learning enables models to train on data sets before being deployed. Some machine learning models are online and continuous. This iterative process of online models leads to an improvement in the type of association made between data elements. Due to their complexity and size, these pattern association could have easily been overlooked by the human observations. After a model has been trained, it can be used in real time further learn from the data. This improvement is accuracy as a result of the training process and automation that are part of the machine learning. Now, in the above discussion, we came across few terms which we need to understand. The first is machine learning, second is AI, third is we need to understand we will learn from data rather than rather than explicit programming. Now let's elaborate this line in brief. So machine learning is a part of an AI in which it enables a system, okay, to learn from data rather than through the explicit programming. Okay. However, the machine learning is not a simple process. As the algorithms ingest training data, it is then possible to produce more precise model based on that data. Okay. So what is how this all thing is going on when you're making the revolutionary change that will get a learning from the data than through the explicit programming. But yeah, because as we know that whatever work we need to perform in the computer science, we need to take care of the explicit programming. But here in the machine learning, we will introduce the algorithm part to train our model, where a data is a part, you know, where is the proper input process and output structure is defined and it is implemented. So the algorithm in just training data, it is then possible to produce more precise model based on that data. Okay. Now with that input algorithm, with that input, we will train our data, to produce a precise model based on that data. So a machine learning model is the output generated when you train your machine learning algorithm with data. So here we came across that no explicit programming is there, that machine learning is putting the algorithm with data, and it is in a training, actually in the training from which we able to give we get a knowledge from this information. Okay. After training, when you provide a model with an input, you will be given an output. Okay. For an example, a predictive algorithm will create a predictive model. Predictive algorithm will give us a predictive model. Then when you provide a predictive model with data, you will receive a prediction based on that, on the data, and that is a train the model. Okay. Now this is something is introduction of the machine learning. Machine learning is simple. It is not like the part where we here in the machine learning we try to train the data with the help of algorithms, and with the help of algorithms we try to make some machine learning models. Okay. And that machine learning model, will take care itself about the person, take care itself about the some result which we try to get from our data. It's like simple how we humans train their mind. With the experience they get better. And like an example, if I need to make a routine in a kitchen, if I keep doing for the last 3-4 months, and I will able to make a very precise round routine, you know in the full cup form. That's how the human brains works, and that's how this models works actually. So when with the help of the machine learning, we try to predict, we try to make a predictive models where we predict with the data that this what I, Yash has come last month, and we were able to gear up ourselves against that storm only because we have our data. IIT Kanpur has just given the exact timing of the COVID-19 second wave of COVID-19 upsurge from their data model. So this is where the prediction models were. We try to give a predictive model with data and see the prediction based on that data. That's train the model. Okay. So this is what the machine learning is all about. Why I'm giving this, the what has been written, that the machine learning works with the algorithm with data. Though second unit is all about data analysis. The first one is data analysis. So for that data analysis, we need an algorithm. This is all regression, multivariate, Bayesian, rule induction, neural network, fuzzy logic. These all are algorithm based. And actually the second unit is a study of algorithm, to be precise. So for your information, it is it. It's like a algorithm learning. Let's go and move towards the iterative learning.
So machine learning enables models to train on data sets before being deployed. Machine learning enables models to train on data sets before being deployed. Some machine learning models are online and continuous. So what are some machine learning? Some machine learning models are online and continuous because we usually get a different type of data and a different frame of data. Okay, so a continuous aspect is taken care. Okay, so we can train different type of models, and for that we use an iterative learning. Okay, and iterative learning is a we use to get the things round and round and round till we are able to get out till we are able to get our objective. Okay, machine learning enables models to train on data sets before being deployed. Okay, before being deployed, we used to train the machine learning model on data sets. Some machine learning models are online and continuous. So some machine learning models are online and continuous. Okay. Uh, this iterative process of online model leads to an improvement in the types of association made between data elements. Okay. Due to their complexity and size, this pattern and association could have easily been overlooked by human observation. This pattern and association would have easily been overlooked by the human observations. After a model has been trained, it can be used in real time to learn from data. The improvement in accuracy are a result of a training process and automation that are part of the machine learning. So what we are discussing actually this. In the machine learning, we are able to get a better result by the training, and that training as a iterative model of learning. There are no let's go ahead. We have a different approaches of the machine learning. Actually, we can say that, or a techniques of the machine learning. It's like machine learning techniques are required to improve the accuracy of predictive models. So, depending upon the nature of the business problem, see why the nature of the business problem is a very important one, because nature of a business. So we are a pack of words today, right? What you? Because nature of the this nature of the problem will give us different the nature of the problem depend upon the business need, and the business need is like depend upon the data sets. Okay, so for the different business need, no, that's something we need to take care, that to define the approach, because approach is always depend upon the business perspectives. Because business gives an idea how to approach the problem. In this section, we discuss the categories of machine learning. So what is categories of the machine learning is all about? First is supervised. Supervised learning typically begins with an stabilized set of data and a certain understanding of how the data is classified. Okay. Here, the data set has been classified in the very formative way. Supervised learning is intended to find a patterns in data that can be applied to an analytic process. Okay. That can be applied to an analytic process. This data has labeled features that define the meaning of data. This data has the labeled features define the meaning of data. For example, you can create a machine learning applications that distinguishes between millions of animals based on images and written descriptions. This is like this. Okay. Okay. So first of all is a supervised learning. The second one is unsupervised learning, where we haven't any set of requirement. We have a massive amount of unsupervised. Supervised learning is like we can say that it's like data and where we have a set patterns of data like in SQL and all. Okay. In this unsupervised learning, we used to get a algorithm and application on the massive amount of unlabeled data. For example, social media applications such as Twitter and Instagram and Snapchats and all those things. So understanding the meaning behind this data requires algorithm that classify the data based on the pattern or cluster lines. Unsupervised learning conducts an iterative process, analyze data without human intervention. Very important. It is used with email spam detecting technology. There are far too many variables in legitimate spam emails for analysts to tag unsolicited bulk emails. Instead, machine learning classifiers based on clustering and association are applied to identify wanted emails. Okay. So let's move to the third part, that is a reinforcement. This is a reinforcement learning. See, in the reinforcement learning, it is a business based. Actually, the thing is, it's a business based thing. Reinforcement learning is a behavior learning model. Algorithm receives feedback from the data analysis, guidelines the user to best outcome. Reinforcement learning differs from the type of supervised or unsupervised because the system is not trained with the sample data. Rather, the system learns through trial and error. Therefore, a sequence of the successful decision will result in the process being reinforced because best solves the problem at hand. And with this machine learning, we get a definition of the deep learning as well. Deep learning is a specific method of machine learning that incorporates neural network in successive layers to learn from data in an iterative manner. Okay. Deep learning is especially useful when you are trying to learn patterns from unstructured data. Deep learning is a complex neural networks are neural networks. What is the neural networks we have? Very complex neural networks are designed to emulate how the human brain works. So computers can be trained to deal with poorly defined abstraction and problems. The average 5-year-old child can easily recognize the difference between his teacher's face and the face of the crossing guard. In contrast, the computer must do a lot of work to figure out who is who. So this neural network and deep learning are often used in image recognition, speech, and computer vision applications. So we need to work with the data. For that, to understand the big data in the context of the machine learning as well. So the big data in context of machine learning is like machine learning requires that right set of data be applied to a learning process. Okay, an organization does not have to have big data to use machine learning techniques. However, big data can help improve the accuracy of machine learning because we have a variety of the data in that. So with big data, it is not possible to virtualize data so it gets stored in the most efficient and cost-effective manner, whether on premises or in cloud. In addition, improvements in network speed and reliability have removed other physical limitations associated with managing massive amount of data at the acceptable speed. Add to this the impact of changes in the price and sophistication of the computer memory. So how we virtualize the thing now? With big data, it is not possible to virtualize data, so it can be stored in the most efficient and cost-effective manner, whether on premises or in the cloud. In addition, improvements in network speed and reliability have removed all the physical limitations associated with managing massive amount of data and at acceptable step. Add to this impact of the changes in the price and sophistication of computer memory, because for data we need a memory, and it's not possible to imagine how companies can leverage data in a way that can have been conceived only 5 years ago. So with the help of the data, we are able to get our thing done. Okay, let's move. How have we applied machine learning to our business needs? The machine learning offers potential value to the companies trying to leverage big data and help them to better understanding the subtle changes in the behavior preferences of customer satisfaction. So business leaders are beginning to appreciate that many things happen within their organization. Industries cannot be consistent through a query. They need to understand how the past thing, how the past data will help to get the thing what they want. And it has only happened when they got a hidden pattern and anomalies buried in the data that can help us purpose. How it all come together. So how this machine learning thing is helping in the artificial area, artificial intelligence area. So the advantage of the machine learning is that it is possible to leverage algorithms and models to predict outcome. The trick is to ensure that the data scientists doing the work are using the right algorithms, ingestions the most appropriate data that is accurate and clean, and using the best performing models. If all these elements come together, it's possible to continuously train the model and learn from the outcome by learning from the data. So the automation of this process of modeling and training the model and testing leads to the accurate prediction to support business changes. So artificial intelligence, where we do the reasoning part within the machine, the help of the natural language processing and planning, and for help in the machine in the, uh, for the help we have a subset like machine learning where we do supervised learning and supervised learning reinforced learning, which is neural networks. So what really the machine learning model is all about. So a machine learning model is a file that has been trained to recognize certain type of patterns. Train a model over a set of data, providing it an algorithm that it can be reasoned over and learn from those data. Once you have trained the model, you can use it in the reason for over data. That is, it hasn't seen before and make predictions about data. For example, let's say you want to build an application that can recognize a user emotions based on their facial expressions. So you can train a model by providing it with images or faces and connect with a certain emotions, and then you can use the modern application that can recognize any user's emotions. This training extract patterns from data. This training is all about. Training is extracting the patterns of data. What is your ability to use that pattern to predict results? When to use machine learning? So good machine learning scenarios often have the following common properties. They involve a repeated decision or evolution which you want to automate and need consistent results. It is difficult or impossible to explicitly describe the solution or criteria behind the decision. You have reliable data or existing examples where you can describe the situation and map it with the current result. This is an example of a machine learning side. We understand why this second unit is all this modeling and all. It's really this term data analysis on the way. So in the next lecture, we will go